Hi guys, real quick before the video begins, there have been some Module 14 discrepancies and some issues that I want to go over really quickly. And some of you have brought up some really good questions that needed to be addressed pretty early on. And I would like to take this opportunity right now to address those issues. Especially in Module 14, the walkthrough, where I can fully demonstrate like the full scope of the issues. So I'll go through it one by one. With the question, I was gonna forget. Okay, so the first issue here in Module 14 is that no one knew exactly why this question had like a null of 1, but basically what it is that in this particular experiment where marijuana alters time perception, the experiment has already been done before, and we're going under the assumption that the perceived time is equal to the actual time. So this means before we actually do the legitimate experiment, we are recruiting participants that are capable of listening and accurately defining how long each tone was, given how many seconds they were there. And so the marijuana is meant to alter this time, and we're seeing by how much does it affect their time perception. And because this is like mentioned, this is why in this specific scenario, the null is 1. And then there is another instance in Module 14 why some people were not able to understand like why. Did I even? No, I didn't even. Wow. Okay. Yeah, that's my bad. But yeah, let's go back here. Okay. So some people were not able to fully understand like what variance was. Hang on, where's that thing? I'm gonna find the thing real quick. Perfect. Okay, so this is specifically in which chapter is this? Yeah, I think this is the drug pain easy double rejection. Okay, you can see here in a graph like this one how the variance is not pretty much the same. So I'm gonna take like a snapshot of this. Ugh. Right, come on. Why is everything so slow? Geez. Okay, so you can see in this particular graph how like the data points just keep growing out of proportion, sort of making like this weird. Oh my gosh. I don't even know what's happening anymore. You can see how like it's growing out of control and like there is no consistency, while in the OneNote it is somewhat consistent, somewhat making a channel. While if you were to compare it here with the black pen, it's just growing and growing out of control. And so this would mean that the question is not same variance, because like there is no consistency and there is no similarity in the measure. And so this is why you would say that this does not have the same variance. Other than that, with the question, it should tell you pretty early on that certain questions are in fact normally distributed. So it says usually normally distributed, and this independent from variance thing. It should say the variance is approximately like different from the mean. That's usually like extra information, not necessary. And yeah, that's what it pretty much is. So yeah, that clears up most of hopefully that has cleared up most of the confusion that is there with Module 14. In the rare instance that you do get like let's just say in the rare instance, let's just say you get the chart and your research hypothesis is not supposed to be C, but it's in fact one of the two where it's like A, where HR is greater than 0, then you would have to say that the lower bounds is negative infinity, and the higher bounds, which is equal to alpha 0.95, technically 1 minus. That's the other way around. Maybe I should zoom in here. Yeah, real professional. 1 minus. I was about to do infinity again. Don't mind me. Okay, 1 minus alpha, which should give you this, and then in this case, you should put down whatever 0.95 is, which should give you that specific value. So you'll have this. I think it's F or T. I could be wrong, and then it would be like 3.4877, like some weird number. I'm pretty sure this is not a number, but it should give you some weird number. And you should do the same thing for the rare case that it's B, where the HR, like research hypothesis, is okay. There's never going to be a scenario where it's like less than 0. It's probably going to be like less than 1 or something. So it's going to probably be like a negative 1.9477, which is equal to the alpha. Okay, then the F, and then the 9.5, which is going to be infinity, which you should type out as in the answer, but sometimes it may not give you that option of typing it out as infinity. So be careful what your research hypothesis is here. So yeah, be extremely aware of that. And in the rare chance that you do get this scenario, what you would do here is you would use the negative or the positive value, depending on whichever one of the two you're given, and you would substitute them here where specifically. So if it's like positive, plug in the positive value. If you had positive infinity, you would use the negative like 1.9 whatever 477, and you would plug in the positive version over here, so the plus 1.9477. And the same can be said about this one. If it's you get a positive one and the research hypothesis is like something weird, I think I might have I think I might have messed up here, the difference between the two. But yeah, you get the general idea. Switch them up because you need to calculate the lower confidence interval and the upper bound confidence interval. Hopefully that clears everything up. These are all the confusing main questions that may have popped up for Module 14, and hopefully I've cleared up any confusion. Now, on to Module 15. Hi guys, Mr. Dr. Logic here, and I know the exam has passed for most of you for doing PSYCH202, but I really want to get this out of the way because this is more of a pride thing more than anything else. And I apologize for not getting this out any sooner, but I've hoped I have helped enough of you to get through to this. So I'll just be going through this real quick, and we'll be done in a jiffy. Don't even know what that word means. Okay. So for an experiment like this appears to be categorical. How many categories are there? So each category here is different. So fair and F is different. B and mod are different. So this is 20. And by the way, there are only 1 out of 2 questions for this, so I should be done this pretty quickly. Can a person be classified belonging more to... No. They cannot. Otherwise this would be quickly eliminated. Yeah, they're independent. No, this is not single factor because the factor for grade and factor for fairness are different. How many degrees of freedom? Okay, so I'm going to take the total number of rows. So 1, 2, 3, 4, 5, and the total number of columns, and subtract them each by 1. So rows minus 1 and times columns minus 1. So that's 5 minus 1 times 4 minus 1. So that's 3 times 4, that's 12. Alright. So now I have to determine the predicted frequencies by sum of row totals and sum of columns. So let's start off with that. So we're looking for a very fair F. So 9 plus 2 plus 23 plus 21. That's 55. You know what? I'm just gonna make a little sticky here. I don't know why they both show up. Bring this down. What's the N? N is 615. Okay, so C1 is equal to, what was C1 again? 55. C1 is equal to 55. So I'm just going to finish column 1 first and then continue with the rest. And this is going to take extremely long because the thing, like, I don't know how to describe it. The calculation is going to be very tedious. And if you get one wrong, you're screwed. So 55. So I'm going to do it again just to double check. Plus 2 plus 23 plus 21. 55, okay. So now we got to do the row. 9 plus 10 plus 22 plus 11 plus 22, 74. So here's what we're going to do. 74 times 55 enter divided by 615. And because this is asking for whole numbers, right there, it says it whole numbers, I'm going to put this as 7. So row 1 was equal to, row 1 equal to 9 plus 10 plus 22 plus 22 plus 11. 74. Okay, so now for 2 plus 11 plus 24 plus 14 plus 16, that is 40, 54, 57. Hopefully I did nothing wrong, otherwise I'm going to freak out. So what we're going to do here is 67 times 55 times 650, that's 6. We're going to do the same thing again, 23 plus 34 plus 111 plus 59 plus 56. Oh my gosh. Row 3 is equal to 283. 23 times 55 divided by 615, that's 25. Row 4, yeah, there's only one more row and that's it. And so row 4 is 21 plus 22 plus 97 plus 25 plus 26, that's 191. And then so 191 times 55 divided by 615, that's 17. Now let's move on to D. So its column is 10 plus 11 plus 34 plus 22, that's 77. So now what we're going to do here is 74 times 77 divided by 615. And immediately the right way of looking at to do. Most of you already know how to do this, but yeah, I'm getting out of the way. This is the right thing now. 77 times 67 divided by 615. 8. 77 times 483 divided by 615. Also, I'm hitting enter like before, so that it doesn't mess up the calculation for some reason. 77 divided by 615. 24. Now as for C, C3 is equal to 22. 22 plus 24 plus 111 plus 97. Okay, so we're dealing with numbers. 254 times 74 is looking for 1301. Enter divided by 615. That's 31. So for C mod fair, that's 254 times 67 divided by 615. 28. Just want to try something out. Yeah, let's try again. 4 times 67. I guess that's the same answer. We didn't enter unnecessarily, but oh my gosh, I didn't know I did this wrong. 4 times 8 divided by 16. 7 right over here times 4 divided by 16. 79. And then 64 equal to, what's that? 11 plus 14 plus 59 is 25. 109. 74 divided by 16. 15. 109 times 7 divided by 16. 12. 109 times 3 divided by 16. 50. 1 times 109 divided by 16. 34. Okay, and so finally, for the last column, 65 equal to 22 plus 16 plus 56 plus 26. 120. Here, 120 times 74 divided by 15. That's 14. 120 times 67 divided by 15. And 13. Now, 23 times 120 divided by 15. 55. 191 times 120 divided by 650. Okay, here's the moment of truth. Let's see if I did everything right. Oh, thank God. All right. Okay, so here the correct answer would be for the chi-square one, because this is not what we're looking for. This is not what we're looking for. I feel like these two are dummy answers meant for like the previous course, like last semester. So this would obviously be a C. The x obtained null is equal to the df, so this would be 12. Okay, I haven't been able to mention like the actual reason as to why this is the correct hypothesis, but basically, hang on. Let me just pull up OneNote real quick. Hurry. Module 15. So basically, when we draw, and we're given the graph, this and this, the x obtained will look like something like this with a tail. So this is how we know it's the x obtained value for the chi-square. And let's just say this was equal to our df. Okay, I know it doesn't help the fact that it's in that color, but let's put that red. And so this would be our df value. Now it's actually incredibly rare for you to get a DF value in this range. So that's why 99.9% of the time, your research hypothesis is going to be over here where it's greater than the DF. This is just mathematically speaking, this is how it just turns out. And this is because of the equation we were given earlier, where obtained minus expected squared divided by expected. It's so incredibly rare for it to end up here that it's statistically possible, and because of that, it's 99% of the time it shows up here. So that's why the research thing is A. Okay, so this is actually more tricky than it perceives itself to be, but what we're going to do is pretty much that formula, obtained minus expected squared divided by expected. And because it's this question, it's legitimately going to take forever. Oh, shoot. Where did that go? Okay, I'm not going to be typing all the digits up, but I will do this. Come on. Not like that. Let's shrink you. Put you... Oh, what the heck? Why is that not working? That's so weird. Okay, you know what? I'll just put you right over here. Squeeze you in a bit. Bring you up a little. And yeah, this is what we're going to do. So obtained minus expected squared 17886. So this is how we're going to do the first answer, and this is what we got to do. I got to do 20 of these. Oh my gosh. This is going to take a while, so I may speed up this process a bit. You know this. Just focus on A. Look at that solid state. Probably the next music playing background. You know this pain go away. No idea how I got the patience to do this. Probably all the stress is on, and I'm able to do this all pretty well. I swear, this is my practice as a recording. I'm gonna freak out. The recording good. Finally. Done the last one. Alright, okay. I think I've stopped at the correct spot where it's like I have done all of them. Hopefully I've done them right. So yeah, I've done all 20 of these bastards. And so now I gotta copy paste all of them and just add them all collectively and turn them into 2 decimal points. This was a pain in the ass. I'm gonna freak out. What? No! Oh my god. I think I broke it. Fantastic. Copy. Actually, you know what? I got a better idea. Instead of doing it on you, duplicate and bring it over here on you. Wait, can I just sum? Not what I was expecting, but okay. I gotta do it all again. Okay, so all 5 digits are included. 2, 3, 4, 5. 1, 2, 3, 4, 5. Last one. Oh no. 1, 2, 3, 4. Alright, that's one. Okay, so I think it's 25.68. Oh, thank God. Okay, so I think this is C, chi square. Okay, in the instance that this is below 5, this is the closest number below 5, this would be other. So since we don't have that scenario, this is an other. Oh, that took way too long. That took way too damn long. Okay, so PF is equal to 12. And we're looking for 0.095. Oh, would you look at that? It's 23.3367. And since our thing earlier was 25, that's way above, so we're going to reject this. Oh my god, that took for damn ever. That shouldn't have been long as it was. Alright, let's see this. Let's see this. Okay, again, this is categorical. How many categories? Okay, so in this case, according to this question, oh, you sneaky son of a bitch. I remember you. Do not specify. There are 7 categories. You sneaky son of a bitch. See? You sneaky. No, they're not allowed to. They are independent. The reason it's no is because you don't want to ruin it. Consider single factor. This one is single factor. Okay, thank God. How many degrees of freedom? Okay, rows. Okay, you can't have like columns and rows equal to 0. They have to always be 1. Okay, if there's 0, that in the scenario where it's like you calculate both, they can't be. So in this case, it's 1 times 7 minus 1, so that's 6. Here we are again. Oh gosh, I hate you so much. How many people we have? Okay, so we have an N of 1360. Look at how much we have. I'm gonna get rid of you. I'm gonna bring you back. And put you over here. And so what we're gonna do is we're gonna take 1360 times. Let me just copy this first. 54.1089%. Damn it. Okay, since this is a percent, we would push the decimal places 1 over. So in actuality, since we're rounding this to whole numbers again, this would actually be 736. 0.109331, 149, 0.035762, 49. Let's just wait. 0.199262. Okay, so that's 2, 1. Okay, 0.054680. I gotta make sure I'm typing the right thing. 74. 0.049780. 68. And then lastly, 0.010170. 14. Hopefully I've done everything right, like typing it in and whatnot. Okay, so everything is right. That's good. Again, trick question. The answer is C. Always has been. The DF. In this case, it would equal to the DF. To get wrecked. A, as previously explained. And this nightmare once again. 705 minus 735.067. Gonna bracket the two. Square it, divided by U once again. At least it's 6, not like the last one where we had to do 20 of them. Oh my god, I still hate that. I still hate that. 48.68983. And then we're just gonna copy this again. 400, 61, 486, 36, 05. And we'll do that. Oh my gosh. Oh, we're halfway there. Come on. 0.2, 270, 99, 5940. Copy, paste. I'm doing like this for transparency, so I know when I'm like, if you guys were to do this with me, like, I'm not pulling strings, we're just doing the same thing together. 4, 3, 6, 4, 4, 2, 2. Oh, there we go. We'll do 8, 3 zeros, 76, 50.830, 76. Okay, I'm gonna add all them up. Oh, that's gonna be pain. So we'll do -4. Come on, everything's right here. Yep, 1.931977. Okay, so according to this, it is 37.35, unless I screwed up somewhere, which I hope I don't. Oh, let's go. Okay. So for this case, we've never had anything below 5 in the predicted frequencies, so we can safely say D is not the right answer. A and B are not the right answer, so we can default to C. So again, the DF was 6. And because we had the alpha, I know I didn't mention this earlier, but this is the alpha, and since we're looking for it in the positive range, as mentioned earlier with the research hypothesis, this is where we're going. So 14.4494. Obviously we reject because that thing was like a high 30. And with that, we're done. That took way too long than it should have. Hey guys, one last thing before I end it all. Thanks for joining me on this crazy series that is PSYCH202. And there will be a video, as mentioned, like pretty early in the video, that will come out shortly explaining the whole dilemma and why Module 15 took longer than it should have and why the video never came out to begin with. Anyways, that's it. I hope that's helped almost everyone with their issues. I might create a PSYCH201. I know it's kind of older, but I kind of came up with this idea on the spot thanks to a help from a certain someone. But that is it. I'll be starting a new journey with a new series that I technically completed last semester, but I'm not happy with the note I ended it on, and I would like to end it on my own note, despite I just finished the exam, so I don't know how I'm going to do on it, but update soon to come. So thanks for joining me on this crazy adventure, and take care. And hopefully everyone did well on the course.